In this video, we're going to solve using the quadratic formula, and we're going to use the quadratic formula in graphing to solve vertical motion model application problems. So in the first two, all we're going to do is write an equation, either a drop or a throw, depending on what's happening. So in number one, it says a stone is dropped from 20 feet above the ground and falls and hits the ground. So that means our start height is where the stone started at, so 20 feet. Our end height is 0 because it's hitting the ground. And in this case, the velocity, we don't have one because it's just being dropped. So we're going to use our drop equation, which is h equals negative 16t squared plus s, and we're going to substitute the h and the s values in. So we're going to have 0 equals negative 16t squared plus 20. And then if we were going to solve, we would use our calculator, but for now we're just writing the equations. In number two, we'll toss a ball up in the air from a height of 4 feet with an initial velocity of 30 feet per second, and Chris catches the ball at a height of 3.5 feet. So we are throwing the ball up, which is important when we're starting to determine things. So our start height is 4, that's where the ball started at. The end height is 3.5, that's where it was caught. And in this case, we do have a velocity. It's going to be positive because the ball was thrown up, so our velocity is going to be 30. So I can substitute into the throw equation, which is 8 equals negative 16 t squared plus vt plus s. So we have 3.5 equals negative 16 t squared plus 30t plus 4. In the last problem, we're going to use the information for the following questions, and we're going to solve. So Sammy lives in an apartment building that's 54 feet above the ground, and Greg lives in an apartment that's 36 feet above the ground. If Sammy drops a DVD down to Greg, how long will it take for the DVD to reach? So we have one person that's up here that's at 54 feet, and they are dropping to another person that's at 36 feet. So in this case, our start height is where the DVD started at 54 feet. The end height is where Greg caught it at 36 feet. And in this case, we are dropping it, so there is not going to be a velocity. So when we set up our equation, we have the end height 36 equals negative 16t squared plus the start height of 54. So we're going to use our calculator then to see how long it's going to take for the DVD to reach. So I'm going to go to y equals, and for y1 I'm going to put in 36. And for y2, I'm going to put negative 16t, and instead of t, I'm going to use the x button, squared plus 54. Now, before we graph, we should probably fix our window. So we're going to use the x max as 0. We're going to leave the x max at 10. The y min, we don't want negative time, so I'm going to just move that up to negative 2. The y max, now the biggest number of the problem is 54, and we want to make sure we see the whole graph, so we're going to go a little bit above 54. I'm going to go to 60. I'm going to hit graph. So we see our graph in the intersection, so we're going to do second, trace, intersect, move close to that intersection. Now that we're probably close enough, we're going to enter 3 times. And we get our intersection as at x equals 1.06. So we're going to say t here. So t equals 1.06 seconds. That's how long it'll take the DVD to drop. If Steve comes over to watch the DVD at Greg's apartment, Greg throws his keys down to Steve with a downward velocity of 22 feet per second. If Steve is bad at catching, how long will it take for the keys to hit the ground? So our start height is where we're throwing the keys. Remember that Greg lives 36 feet above the ground. The end height, because Steve can't catch, is going to be 0 because it's going to fall and hit the ground. And our velocity is downward, so it's going to be negative 22 feet. So when I set up my equation, the end height equals negative 16t squared minus the velocity negative 22 times t plus 36. So in our calculator, we're going to change the y1 to 0. We're going to change the y2 to negative 16x squared. Negative 16x squared minus 22x plus 36. And our window should be good because it's using the same stuff from the other problem. So we have our intersection point. We're going to hit second trace 5. Move close to that intersection point. So now I don't see the cursor, so I need to keep going to the left until it gets on that intersection point or closer to it. And right now we're only at x is 3. Now we're close to our intersection, so we're going to enter 1, 2, 3. And our intersection is going to be t equals 0.96 seconds.